Hello my dear students, welcome back to NEET World. So today we will be discussing JEE previous year questions, exclusively JEE questions. And here the first question we have is the pH of a 0.02 molar NH4Cl solution will be how much? So given data Kb is given and log 2 value is given. See, salt hydrolysis, one of the very favorite topic of JEE examiner. Okay, so now look at here. So whenever you hydrolyze this NH4Cl, what is the compound formed here? NH4Cl upon hydrolysis forms NH4OH plus HCl. Right now it means we are getting a resultant, we are getting a strong acid, therefore the solution will be, the resultant solution will be acidic. Therefore you can use this direct formula here I am giving. pH equals to 7. So since solution is acidic I am saying now, because see chloride ion can be removed, so the resultant solution is having H plus ion concentration, right? Okay, along with this base we have H plus ion concentration, right? So since H plus ion is coming from strong acid, I can say this is a this might be having pH lesser than 7, it means acidic solution, right? So lesser than 7 means pH equals to 7 minus half into here, see 7 minus, why? Because pH has to be lesser than 7 since it is coming from it is a salt of a strong acid, right? Now strong acid plus weak base, so 7 minus half into, use here pKb, okay? So Kb of this weak base, so pKb I am taking, pKb plus log C, what is the concentration of salt given, take here, okay? So pH will be equals to 7 minus half into pKb, see Kb value given as 10 power minus 5, if you apply minus log of this Kb which is nothing but pKb, right? So this will be equals to minus log 10 power 5 minus 5, so this will be 5, so pKb is 5 here plus log C, so log C is how much? Concentration of this solution is given as 10 like 0.02, I am writing 2 into 10 power minus 2, so you can write here 2 into 10 power minus 2, right? So try to simplify this, see they have given some data also here, so 7 minus half into 5 plus log 2 will be 0.3 they are saying here, so you just use that 0.3 and log, see log A into B we have, so log A plus log B, so that log 2 is 0.3, so minus 2 here I am writing, that's it now, yeah. So what is your answer here? 7 minus 1 by 2, so 5, see minus 0.7 I can write here, right now, yeah. So try to simplify this, what you are going to get here, so 7 minus 4.3 by 2, so this will be around 2.7 right now, so 2.15 right now. So try to simplify this, you are going to get answer around, so 5.35 right now, so 5.35 will be the pH of this resultant solution. Hope this is clear. Now I will be giving you one more concept over here. So this is a salt, NH4Cl is a salt formed from what? It is formed from weak base plus strong acid. So what is the formula I have given you? So 7 minus, because strong acid na, so 7 minus half into pKb plus log C, okay? This is a formula you can use for this kind of salts. If it is formed from combination of weak acid plus strong base like sodium acetate is given, so what is the pH here you should use? So this is a salt formed from weak acid and strong base now, so pH definitely greater than 7 you can say, so 7 plus half into, here weak acid is there now, so Ka, for weak acid we have Ka, so take here pKa, so half into pKa plus log C, that's it. These are the two important formulas you can remember for solving the questions related to salt hydrolysis of weak acid, strong base, or strong acid weak base kind of salts, okay? Yes. Next, let us move forward with one more question here. Choose the reactions, this is a JEE advanced question, so choose the reactions from the following options which for which the standard enthalpy of reaction is equals to enthalpy of formation. See, standard enthalpy of reaction. See, delta H reaction, what is the delta H reaction will be equals to, for formation if they give, so what you should write, formed products, the amount of energy or the enthalpy change that is accompanied during 1 mole of particular type of product is formed from its respective elements in the standard state. So here we have ozone, 1 mole of ozone is formed now, so I can say delta H products minus delta H reactants, right now, delta H formation of products minus delta H formation of reactants. Okay, so this you can take summation of delta H formation of products minus summation of delta H formation of reactants. See, here we are getting ozone right now, so you can take here delta H formation of ozone, O3 I am writing this product side, and reactant side what we have, O2. So what is this O2 standard form is in gaseous state only na, at room temperature or at standard state. What is the elemental state or natural existence of oxygen, that is O2 in gaseous form only, no? So it means the heat of formation of O2 should be taken here 0. Therefore I can say delta H reaction is equals to delta H formation of ozone. So the whatever the question they are asking, that is satisfied by first option. So it is a multi-selective type question, multiple choice answers are there here. Okay, multiple options are there here, you can say multiple selective question it is. See, again like SA, it is a standard form of this sulfur right now. So again ozone oxygen in the gaseous state, that is also standard form, so forming sulfur dioxide. So here also delta H reaction, see how many moles it is forming, 1 mole. So delta H reaction is equals to, so enthalpy of formation of SO2 I can say, and minus, see the standard state sulfur standard state is SA8 right now, so it means enthalpy of formation of sulfur reactant, this one and this one is 0, so here minus 0. So delta H reaction is equals to enthalpy of formation of SO2. So it means our second option is also satisfying the condition. Now what about C and D? See, in the C case, see how many moles of product is forming, 2 moles. Always remember, whenever we are talking in terms of enthalpy of formation, you should take the reaction for per mole formation. It means 1 mole of H2O if it is formed, then we can write enthalpy of formation. Since it is not exactly representing enthalpy of formation, so I can say this is not valid option for the given question. Again look at here, see C2H6, 1 mole of C2H6 is forming, that is perfect, but here see what is the standard state of carbon, it is graphite now, which is solid in form, but they have mentioned physical state as gas. So this is also not representing the exact indication of, or not satisfying the exact condition given in the question. So your option C and D are incorrect, only A, B are correct for this particular question. Very easy, right? So whenever you are doing some questions for JEE mains, if you are really preparing for that, since you have some more time now, so just go through few questions at least of advanced, JEE advanced. Okay, so wherever the concept you feel more confident, first try from those questions, just try advanced question from those topics wherever you feel more confident. Okay, so then later on you can try other topics also. Okay, right, let us move forward with few more questions. Yeah, so identify the major product C in the given sequence of reactions. Okay, so tell me, here we have acetone, ketone is the starting material, treating with Grignard reagent, methyl magnesium bromide, okay, followed by hydrolysis, you are going to get A. So what is this A? First identify that. Yeah, so see, whenever you have acetone, which is carbonyl compound here, ketone I can say, methyl magnesium bromide we have, this is a Grignard reagent, which is nucleophile, strong nucleophile, and here ketones like this carbonyl group, oxygen will drag the pi electrons, creates electron deficiency here, and methyl group attacks here. So you are going to get a tertiary alcohol like this. Okay, like this you got a alcohol, this is our A. Okay, and this A treated with alcohol, treated with thionyl chloride, SOCl2. Okay, what happens, the removal of this OH takes place and replace that with chlorine. Okay, and SO2 gas and HCl gas is liberated. So one of the best method for preparation of alkyl halides or alkyl chlorides from alcohols. Okay, this is your B here. Okay, so this is your B. Okay, B upon treating with methoxide, sodium methoxide we have. Okay, heating. So what happens if you heat that? See, here you have methyl group now. So one of the hydrogen from this carbon and this halogen will be eliminated, like alpha beta elimination takes place to give a product like this. Okay, so because they are saying heating, so heating means dehydration takes place. Okay, like here methoxide will take this H plus from here and elimination of dehydrohalogenation I can say. Okay, chlorine goes out, chlor as a chloride ion. So what is the suitable answer here? You have first option as your answer, right? Right. Okay, let us move forward with few more questions. So look at here, the enthalpy, standard enthalpy for formation for CO2, CO and H2O are given like this. Okay, the standard enthalpy change for the reaction. This is the reaction they are given. Okay, so standard enthalpy change of the reaction, delta H reaction. Okay, and delta H not I am writing for standard state. Okay, so formations are given now. So always remember, for formation, first what are the things forming? Products are forming now. So take product side. What are those? We have delta H formation, standard formation of CO. Okay, plus delta H H2O. Okay, these are the products formed and these are deformed, right? So that's why I am inserting a minus symbol here. Okay, minus reactants you write. Delta H formation of CO2 plus delta H naught formation of H2. That's it. Okay, yeah. So look what are the values mentioned here? CO2, CO is given. So CO, the second value here is how much? Second value is minus 110.5 plus, and H2 third value is minus 241.8. Okay, then next here minus CO2 value is how much? First value minus 393.5. And what about H2? See, the standard state of hydrogen will be gaseous state now here. So it is in the standard state. So it means you can take the value of it as 0, right? Okay, let us calculate this. So you can get this as minus. So both minus are there. So add them. So 13, 3, 1, so 2 and 5 and 3. So minus 352.3 plus 393.5. Okay, yeah. So try to simplify this. You can have a value with plus sign. So here 2, 1, 4, 0. Okay, so 41.2 kilojoule will be your answer. Kilojoule per mole will be your answer. Okay, so here you have now second option plus 41.2, that will be your answer for this question, right? Yeah. So let us move further for few more questions. The following concentrations were observed at 500 Kelvin, the formation of ammonia from N2 and H2. Okay, at the equilibrium concentration of N2, H2 are given and ammonia is also given. They are asking equilibrium constant. They are asking Kc. What is the value of Kc they are asking? So what is the value of Kc? Okay, so look at here. So look at here, Kc value they are asking now. So first of all, write the reaction. So for the following concentrations were observed for the formation of ammonia. Formation of ammonia takes place from N2 plus H2. So first balance the reaction. So 2 nitrogens, so 2 ammonias here. So 6 means 3 hydrogens here. So 1 N2. So Kc means what you should write? So Kc equilibrium constant will be concentration of product. Concentration of ammonia. Okay, whatever the stoichiometric coefficient is there, right here 2. Concentration of ammonia power 2 and concentration of N2 multiplied with concentration of H2 to the power 3 here. Okay, like this. Now this is about equilibrium constant. So look at here Kc, just take the values they mentioned. Ammonia concentration, equilibrium concentration is mentioned as 1.5 into 10 power minus 2 square here, and N2 mentioned as 2 into 10 power minus 2 again. Okay, and for H2 mentioned as 3 into 10 power minus 2. Okay, like this they have mentioned. So here cube. Okay, so now try to simplify this, you will get the answer. Just simplify this, you are going to get your Kc value. Easy only right now. So what is the Kc, you tell me in the chat box. Just simplify that, you will get the answer. Okay, yeah. Next. Look at this, the most acidic species among the following is. So tell me, how can you say acidic species means that should liberate H plus ion. Right now, generally this is how we are considering acidic nature of compounds. Now look at the compounds given. See, if they give H plus ion, which one is the most acidic hydrogen in the given compounds? Like see, this is the hydrogen atom here and this is the hydrogen atom. See, the hydrogen atoms attached carbon is attached to the 3 oxygen atoms. So we can consider this is relatively acidic. Okay. Similarly, here also we have one hydrogen which is attached in between. Now if I remove this H plus ion, so that we are going to get a carbon having negative charge attached with the sulfur atoms like this. Right now, like 3 sides. Yeah. So this negative charge is more stabilized. Why it is more stabilized? Because sulfur has vacant orbital. So to that vacant orbital, this negative charge can be donated. Therefore, this makes the conjugate base of the compound formed from this compound is more stable. Therefore, the second compound is more acidic. So why I am saying this second compound is more acidic? Because respective conjugate base is stabilized by the delocalization of negative charge of the carbon with the empty orbital of sulfur. Okay, that is the main reason. So that kind of delocalization, that kind of stability is not possible in any of these options. See, we can only have inductive effect, minus I effect from here, but there is no conjugation like this to stabilize the carbon ion. Very important question it is. Okay, yeah. So now based on this, I can also give you the other questions also. For example, I am saying H2S and H2O, which is stronger acid here, which is more acidic. Same story, whatever we have learned here, applicable here also. If it releases H plus ion, you are going to get HS minus, and from here you are going to get OH minus. So here HS minus is more stable than OH minus ion, because sulfur can accommodate the negative charge in the empty orbital, which is not possible in the oxygen due to its small size. Right now, and no vacant orbital present in the oxygen, but in sulfur we have 3d orbital, right? So that makes it to be more stable, therefore it is more acidic. H2S is more acidic than H2O. Similarly, this compound is more acidic than the first compound and any other remaining compounds. Okay, right. Let us move forward with few more questions. Using the provided information in the following paper chromatogram, we need to identify the retention factor for compound A. So again, this is a very like easy questions actually. Okay, based on chromatography, paper chromatography, TLC chromatography, thin layer chromatography. Okay, so column chromatography, these are important and easy. Okay, look at here. See, if you look, this is a paper like a thin layer chromatography it is actually. So you have a thin layer of paper, so you kept in the solvent. So before keeping in the solvent, you have two compounds mentioned as AB, which you have to spot it on this bottom line, this baseline. So this is the baseline where you need to spot your compounds here. Okay, like this. So now whenever you kept this spotted layer like this spotted like chromatogram paper in the solvent, so that dots will goes up along with the solvent. So solvent also will goes up like a capillary action you can consider. Okay, so solvent front will move up to here. So what is the distance traveled by solvent front? 5 centimeters right now. So I am writing distance traveled by solvent front is 5 centimeter. Okay, now the distance traveled by component A is how much? 2 centimeter as they mentioned here. So DA, distance traveled by component A is 2 centimeter, and distance traveled by DB, okay, component B is how much? 2 centimeters. That's it. Okay, 2 plus 2, 4 centimeter like this. Okay, now what they are asking, the retention factor, the chromatography compounds A and B, they calculate RF value of A. So RF of A, retention factor of A can be taken as distance traveled by that component. They are asking about RF of A now. So distance traveled by component A and distance traveled by solvent. That's it. Okay, so it means here ds is 5 and dA is 2, that's it. So 0.4. So what is the answer here? You can write 0.4 or 4 into 10 power minus 1. So right here your answer is 4. That will be your answer, right? Yeah. So can you tell me what is the answer for retention factor for RF value of B? So tell me your answer for this question in the comment box. Okay? Yeah. Okay, let us move forward with one more question here. Which of the following compound is not aromatic? See, so we can have aromaticity here right now because it is a cyclic compound, okay, and all the carbons are planar here, sp2 hybridized, okay, and it has complete conjugation like this right now. Yeah, so complete conjugation is also present, and it has 4n plus 2 pi electron system, okay, pi electron system. So this is also perfect. So it is an aromatic compound. So here also satisfies all the 4 conditions, and this naphthalene also satisfies all the 4 conditions that we discussed. So if you look at here, so this is called aniline, okay. So this aniline, see how many carbons are there here? 10 carbons, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can say 10 aniline. So 10 aniline is not aromatic compound here because of flagpole interactions of this hydrogen and this hydrogens make the compound to be non-planar. Therefore, there is no like planarity in the given compound. Therefore, it is a non-aromatic compound. Okay? Yeah. So what is the reason? Due to the flagpole interactions of 2 hydrogens of this aniline, 10 aniline makes it non-aromatic. Okay? So that's it. Becomes non-planar, so non-aromatic, right? Yeah. Next, here among the following, the least stable resonating structure is what? So look at here, whenever you are writing resonating structures, so first thing is most stable compound should contain that resonating structure which is having more number of covalent bonds is considered as more stable. More the number of covalent bonds in the given compound, more is the stability. Okay, that is the first factor. And next, the charge separation should be like charges should be as much as far away from each other. So, but based on this statement, if you look in the first given option, see positive charge, like charges should be separated as much as we can. But here they are very adjacent to each other. If they are very side to each other, so this will be highly unstable. Okay, so which means this will be the least stable when I compare with the others. See, now here we have opposite charges. There is opposite charges is nothing but a bond. Also you can write. Okay, here also you have opposite charges. You can write a bond. But in this case, you just have like charges side to each other right now. So this makes it highly unstable. Okay, unlike charges like positive, negative can be side to each other. Okay, that is not much unstable. But here, this is highly unstable due to the like charges have more repulsions. So whenever they are adjacent to each other, that makes the resonating structure as a wrong one and a least or highly unstable one. So your option number 1 will be your answer, right? Yeah. Next, will you try this question based on this like ideal solution concept? Okay. So which of the following will form an ideal solution? See, in order to form ideal solution, the nature of compounds, let us say I am mixing A and B, these 2 components I am mixing. The nature, the characteristics of A, B should be same before mixing, like whatever the characteristics it has. So after mixing the solution we got, AB kind of solution will get now. So its characters or the properties should be same as like the A and B, individual A and B. Okay. So now for example, if they have same volume, for example 10 volume I am mixing. So after mixing we should get 20 volume, then I can say it is a ideal solution. But if it is lesser than 20 ml, it means intermolecular force between A and B is more. Now what happens? They will come closer to each other, therefore total volume, resultant volume will become lesser than the 20. That makes it to be show negative deviation. And sometimes the intermolecular forces between AB after mixing will be like repulsive, or they can stay away from each other. In this case what happens? In this case what happens? So expansion takes place, delta V, that is greater than 20 here, or I can say delta V is greater than 0, I can say, okay, positive here. So I can say in that case it is a positive deviation. See here, when I mix toluene and benzene, so this is having same kind of nature now, so this forms ideal solution. But if you mix acetone and chloroform, due to presence of intermolecular hydrogen bond, they will come closer, both molecule will come closer, so they will bind very close to each other. Intermolecular forces after mixing is more between the molecules, so that makes to the solution to show negative deviation. Okay, so they form negative deviation, this forms ideal solution. And here also HNO3 H2O, they also have hydrogen bonding, makes it to be close, so it is also shows negative deviation. Okay, negative deviation. Okay, so in the first case it will be having positive deviation. Like this you should understand. Okay, right. Okay, right. So hope this is clear. Option number D will be your perfect answer for this. Yeah. Next, here, can you answer this question? Just give it a try. Look at here, phenol upon treating with zinc, what happens? Phenol upon treating with zinc, what happens? So phenol upon treating with zinc takes oxygen, forms zinc oxide. Okay, zinc oxide is formed, and remaining hydrogen is attached or inserted to the benzene ring, so that you are going to get a benzene ring here. Okay, phenyl ring, hydrogen makes it to be benzene ring plus zinc oxide. Okay, so A2, so A is your 2, and whenever you treat phenol with sodium dichromate here, so this forms benzoquinone, like benzoquinone it forms, like this will be the product in the case of 2. Okay, in the B it will be benzoquinone. Okay, B1. Okay, next. Okay, phenol upon treating with chloroform in basic medium, followed by adding H plus ion. So gives, this is a Nemer reaction. What is it? Reamer-Deamer reaction, right now. So here product formed is salsilaldehyde, like this. So you are going to get OH as it is. Just insert SCHO group, aldehyde group. This is a salicylaldehyde. So C4. So C is your 4. And what about D? See, you have phenol adding CO2 and H plus. So what is going to be happen here? Same like this. So you can add OH, like phenol you have, and just put here COOH, that's it, salicylic acid it is. Okay, so D is your 3. Okay, so A2, B1, and C4, A2, B1, C4, A2, okay, just see here. CO2, salicylic acid, D3, C4. Yes, your first option will be perfect answer for this question, right? So option A is perfect answer for this. Just look at these options, yeah, and match it properly. Okay, yeah. So I hope you have completely watched the session, and session definitely helpful for you, I hope. Okay, now if you are new to our channel, just click on the subscribe button first, and you can stay connected with our channel, and just go through the playlist of this channel first, so that you will get definitely a more useful content. Okay, so if you are expecting any topic to be discussed from our side, so just write in the comment box, we will be discussing them in the upcoming sessions. Okay, and yeah, and if you wanted to join our courses, just contact the mobile numbers which are given in the description box, or you can fill the Google form given in the description box to get more detailed information about our courses. Okay, and you can also join our Telegram group. The link is provided in the description box. Okay, thank you for watching. Stay connected with us.